GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks4Geeks. Geeks4Geeks has a challenge for you. Geeks4Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks4Geeks. Geeks4Geeks has a challenge. Geeks4Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks4Geeks. Geeks4Geeks.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing the GFG Weekly Coding Contest 153, and this is the post contest analysis of this. So, here we would discuss the solution of all the problem. The most important focus of today would be over the intuition based on which the problem needs to be solved. Now, before I move forward, let me introduce myself. I'm Siddhartha Hazra. Currently, I'm an SD at Geeks for Geeks. Besides that, I am a candidate master at Codeforce, and for the past 3 or 4 years, I have been teaching very in Geeks for Geeks itself. Now, let us first talk about the feedback of this problem. Today, this time, the contest was comparatively towards the harder side, but the ideas that were discussed were the ideas that are standard and common. So, but what I feel is, I feel that on the optimal capital, which was the third problem and which had 30 marks, should have been the last problem, according to me. Because the fourth problem was comparatively on the intuitive side, like you could quickly get an intuition of this, but third problem had a centroid problem, and it was to be. What you feel about this, you can tell me. Okay, test case of the last one seems incorrect. Okay, which one can you name it? The cost comparison one? Okay, now let's start off with the very first problem. Let me just share the entire screen and it should make more sense. Yep. A quick speed check, I suppose, because I think so my network is flickering. Just confirm if my network is flickering or not. A quick speed check. Okay, my speed is good enough now. Just let me remove this. Okay, fair enough. I think we are good to go over the speed. Okay. So the very first problem itself, and the very first problem is on the easiest side. Hmm. Yep. So let me just share my screen. My screen is getting shared, and here goes this. Okay. So see, in this problem, kind of we what we can do is we can simply just read the problem and do what is said. So you have been provided with a matrix containing lowercase English characters. Simple enough. Arranged in n rows and n columns. So you are provided with a matrix of n cross m, and what you need to do is, and each one would contain alphabets from A to Z. And your task is to determine if it is feasible to choose four distinct columns from left to right, such that the first column contains P, the next column contains L, the next column contains A, and the next column contains Y itself. That is play. You need to find just play here. So you need to select four columns. Okay. So a matrix would be of this, that is A of 0, 0, A of 0, 1, A of 0, 2, A of 0, 3, and then we have A of 1, 0, A of 1, 1, B of 1, 2, and B A of 1, 3, and this is A of 2, 0, A of 2, 1, A of 2, 2, A of 2, 3. This is enough to find out. So let's say the play is somewhere at this side. Okay. Let's say here we have something like P, L, A, Y. Okay, we have this. Now we need to find out the columns. So here the answer to this would be the very first one, then P, L, A, and Y. We have this. So now what we can do is we can simply have a string here, that is play. First, we would try to find P here. So we would test each row. Okay, try each row. First, we gonna try this row, then we gonna try this row, then we gonna try this row. So if I talk about the first row, let's say we didn't find the solution. Then first we found out P. So now this iterate would go to L, then we would find out L, then this would go for, we would search for A, then we would search for Y. When we are done with getting all the four characters, we would say the answer to this is yes. If towards the end also, after searching all the rows, we are not able to get the solution, we would say the answer to this is no at the end. Showing you the solution, kind of this is simulation based problem. Okay, we don't really need to do that much if you ask me. So here the target string is play, and the number of found characters initially is equals to 0. Okay, so now we would start off, we would take a variable or a flag. Am I going clear? No, it should not be consecutive. It can be anything. The task is to select four columns which contains P, L, A, Y. The ordering should be maintained. But it can be the scenario that after P there is Z and then there is A. It can be the scenario. So we are iterating on each of the columns and the entire row. We would check the entire row for each column. Okay. Then we would say if we found P, then we would say column contains true, and then we would break. Then we would move forward and we would keep incrementing the value, that is found characters. If the number of found characters till the end is 4, that we have found all P, L, A, Y, then at any point if we find that, we would return true because the presence of it is required. And if towards the end also we are not able to find a presence, we would return false. Mostly simulation based. I don't think much is required over here. So I would just copy the solution. So am I clear with the idea? Just give me a quick one in the chat. Am I clear with the idea that needs to be found out? Just give me a quick one. Just give me a quick one. There are 20. So play should be in the same row. Yes, we should be selecting same column here. See where it is written. Let me just show you where it is written that it should be in the same row. I would be showing you. See, your task is to determine whether it is feasible to choose four distinct columns from left to right. This is the point. From left to right. Okay. If let's say A is here and P is here, then if we go from left to right in that, we won't be able to find out. Okay. This is where you get the idea that it should be in the same row. So I am not getting any zeros at this point, so I would simply move forward. Now, so this problem is comparatively, again, what is asked. Let me just tell you. See, we need to find what? Here, we are given a linked list. So we have one, let's say two, and let's say three, let's say four, let's say five, let's say six, let's say seven, and let's say eight. We are given this. Now we are told to find out the XOR pair, like the pair of numbers which has the maximum XOR. So this and this would make a pair, then this and this, then this and this, then this and this. So this and this, this and this, this and this, and this and this. Okay, would make a pair of this. Okay. Now, if this was just an array of numbers, if this was just an array of numbers, so most simple thing what you can do is in an online judge, you can't do this in an interview. I'm just talking about the online judge. You can copy all the numbers in an array. You can copy out all the numbers in an array. Then you initialize two pointers, left and right. Just see this idea. And we can simply say while left is less than r, we would find the XOR value of A of L XOR with A of R. And after that, L should go that side, R should come that side. So L plus plus and R minus minus. And then we would take out the maximum XOR. But what problem is occurring in the linked list? In the linked list, as this is a singly linked list, not even a doubly linked list, the problem is that in a singly linked list, we could have done this in an online judge. If you want to just swiftly get an AC, do this. But let's solve this problem if this is asked in an interview. The problem is you can inculcate two pointers, L and R. But the problem is that this L can move forward, but this R can't move forward backward because we don't have any location to the backward element. Each element stores the location to the next element, but no backward link is present. So one simple idea is that you store the previous of every number, but that is again a bit of hard work. Okay. So the problem is that we can't iterate backwards here. So we know that we would be iterating backwards for this side. So we can just reverse the second part. 8, 7, 6, and 5. Now the new linked list is this one. And this is not present. Now after we did this, now we would have R here. And now this time L and R both would move forward because we have reversed the linked list. So first we would find the half, then from that half to the end we would reverse it, and then in both of them we would move forward. So now if you observe, first we would have the XOR of 1 and 8. Then we would have the XOR of 2 and 7. We would just increment LNR. Then we would have 2 and 7. Then we have 3 and 6. Then we have 4 and 5. Whatever is the maximum value would be our answer. How would we do it? We would find the middle. Then we would reverse the middle to the last. And then we would do this operation, that is L and R, and after each L and R both would move forward, and in a linked list we can move forward. So a simple, if I was giving this contest, I would have simply copied all the values in an array and I would have safely moved forward. Okay, because we are allowed to use extra space in an online judge, but there is no point for over optimization. So the mindset to hit a particular contest is different than what you do in an interview. In interview, the extra optimization marks is given, that yes, this person is given the most optimized solution. But in an online judge, the only if you are rewarded the same point, like let's say I have optimized it to 100% and I have optimized it to 50%, and we both were able to surpass the time limit, then we both would be rewarded with the same amount of score. There is no point for extra optimization. So take this mindset. So now showing you the solution. So we would make slow and fast pointer. By using slow and fast pointer, we are getting the middle of the linked list. Then we reverse the second part of the linked list, that is reverse a linked list. Then we would just take the maximum of this and this, and both would move forward. This is the solution, comparatively again on the easier side. So both the ways I have combined. Now, if you have understood the solution, give me a quick one. Give me a quick one if you have understood the solution. Then provide but says complexity because oh nice idea. Okay, someone please tell me. Okay, nice. Okay, now tell me if things are clear to you or not. Give me a quick one in the chat. Give me a quick one in the chat if things are clear to you. Then I can just simply move forward. Want this to be quick? I think so. For everyone, it is making sense. So I would be moving forward. Okay. So now, if you want to solve problems like this, okay, first I would tell you and explain you this problem, and then we would talk about the other scenarios. Okay. So before that, let me just give me a sec. Okay. So now I should be clear enough. I have grabbed the notebook. Okay. Now see what this question wants you to do. Damn. Okay, let's go over this again. My audio and all should be clear enough. See, bacha. Here in this question, you are given a acyclic undirected graph with n minus 1 edges. So here it is acyclic because we have n minus 1 edges. So if you observe, if we add an edge from anywhere, it would contribute a cycle. If we add an edge here, if we add an edge here, if we add an edge here, if just add one more edge and you would have a cycle. That is why n minus 1 edges and acyclic and undirected confirms that this is a simple graph. Okay, now what you need to do is you need to find the cheapest central node. What do you mean by central node? It's just that the cost to all others, the sum of cost to all others. Like for this, let's say, let's start with 4. So if we start with 4, the cost to reach 4 is 0. The cost to reach 1 is 1. The cost to reach 3 is 2. The cost to reach 0 is 2. The cost to reach 2 is how much? 3. So 3 plus 2, 5, 5 plus 2, 7, 7 plus 1 is equals to 8. That is why for this node, the sum of cost to visit all other nodes is 8. Now let's talk about 3. So the cost to reach 3 is 0. The cost to reach 4 is 2. The cost to reach 1 is 1. The cost to reach 0 is 2. Damn, I missed it. The cost to reach 3 is 0. The cost to reach 4 by using up this path is 2. The cost to reach 1 is 1. The cost to reach 0 is equals to 2. And the cost to reach this one is 3. So 3 plus 1 to 5, 5 plus 1 6, 6 plus 2 is equals to 8. So the final cost of this is also 8. Okay, am I clear with this? Okay. Just a sec. Yep. So now again, for this node, the cost to reach this is 0. The cost to reach this is 1. The cost to reach this is again 1. The cost to reach this is again 1. And the cost to reach again this is 2. So 2 plus 1, 3. 3 plus 1, 4. 4 plus 1 is equals to 5. So this one would be 5. Now, again for this node, the cost to reach here is 1. The cost to reach here is again 1. The cost to reach here is 2. The cost to reach here is 1. The cost to reach here is again 1. Now, the cost to reach here is 1. The cost to reach here is again 1. I have a problem with the pencil, so let me just do the C. The cost to reach here is 1. The cost to reach this node is also 1. And the cost to reach this node is 2. And the cost to reach this node is again 2. So 2 plus 2, 4. 4 plus 1, 5. 5 plus 1 is equals to 6. Okay. Now, the cost from this node to reach this node is 1. To reach this node is 2. To reach this node is 3. To reach this node is again 3. So 6, 3 plus 3, 6, 6 plus 2, 8, 8 plus 1 is equals to 9. So we can say that. So out of this, which is the cheapest central node? It is none other than the winner is 5, that is 1, with a cost of 5, because the summation of cost to everyone is 1. So this is what is asked in the question. And if there are two nodes with the same cost, same minimum cost, we would select the one with the lower value. Okay, so if there was zeroth node, like if let's say this zeroth node have this value of 5 only, then this would be the answer. Am I clear with the question? What the question demands? Give me a quick one. Am I clear with the question? What this question demands? Mm-hmm. Just give me a quick one. What this question demands should be clear. Okay. देखो बच्चा, ध्यान से. Okay. So now in this question, the brute force solution to this is that we find out these costs for everyone and then we take out the minimum value. We can do this. So now see what we can do is, for this we say that for you, let's find out this value. So what we can do is, we can say, let's say we want to find out the value for 0. So we would say 0 has a value of 0. So to reach all the descendant of 0, it would be plus 1. Like let's say my father, what I meant to say is, this is my father and I am his son. Let's say this is my father and I am his son. So my father is my father is the 5th generation. So my generation would be my father's generation plus 1, that is 6th. In the same manner, what I can say is, the cost to reach the source is 0. मुझे अपने घर से घर तक जाने का जो कॉस्ट है वो 0 लगेगा. And the cost to all my descendant is my cost plus 1, that is 1. My 0 plus 1. And the cost to reach this is again 1. Then for this node, all the descendant of it would have a cost of parents cost plus 1, that is 1 plus 1, that is 2. 1 plus 1, that is 2. And if we sum up all the cost, that is 2, that is again 2, and 1 plus 1, 1 plus 1 plus 0, it would be equal to 6. So by using a simple DFS for one node, we can find out its cost to all other nodes. Okay, so doing a DFS is a big O of V plus E, but as the number of edges are n minus 1, so we can say that the time complexity to calculate the cost of one node is big O of n. Okay, so if we do this for n nodes, multiply n on both sides, that would be big O of n square. What is the value of n? N value is 10 to the power 5. So 10 to the power 5 multiplied by 10 to the power 5. The base is same, so the powers would get added. It is 10 to the power 10, which is greater than 10 to the power 8. So we would get a time limit exceeded if we use this approach. Now, do I make sense? What is the brute force solution and why it won't work, and how the brute force solution would be implemented? Do I make sense? Give me a quick one. No worries. There were no sound for no sound from question 3. I just repeated the whole of it. Anyone who didn't understand, give me a 0 for that. I would be more than happy to explain you again. It's you who should have the courage to understand it again. Like I, as a teacher, as this is my work and I have been doing it for many years now, it is not a headache for me. This is not something new to me that I lost my audio and all. There are some technical problems due to which I can't move forward. Like this is very common to me in my career. Fair enough. As of now, most of you are able to comprehend because I received no 0. So I would move forward. So now here, this kind of problems comes under the category of rerouting, centroid calculation, and shifting the route at each step. So we would keep the cost, we would remove everything else. Okay, so now we know what do we want. Okay, what do we want? You would use the same graph. So what I do is, the idea is, and how we would do is I would explain. The idea is find the cost from one node and find the cost of one node and find the subtree size of every node. These two things you need to do, and then we would start the process of rerouting it. Okay, so now let's say these all values are the correct values, but we are hiding it. Let's say these all are hidden. Let's say these all are hidden now. This is a simple graph now. So what I do is I start with the value. I start a DFS from 0. I start calculating the subtree size of everyone, as well as I calculate the value for 0 by using that simple brute force approach. And we do this for just any node. You can do this for any node. I am doing it for 0. Okay. So now I would say, see, I would, this would have a subtree size of 1. This would have a subtree size of 1. This would have a subtree size of 1. And this one would have a subtree size of the children's, that is 1 plus 1 plus the same one. Like what we can really do is, see, what I say is like finding out the subtree sizes for everyone. Now we want to find the subtree size first. How would we find the subtree size? Let me explain you that also. The subtree size, finding out subtree size is easy. What I say is the idea is comparatively on the simpler side. Okay. I have, let's say I am a boss of my company. Okay. And there are two members below me. There are two members below me. I have two members below me, and below them, they also have interns under them. Interns under them. So now I want to find out the size of my team. How would I do it? The interns would return a 1 from them. So 1 plus 1. So this person has two interns. So those two interns plus himself is the size of the small team, that is 2 plus 1, that is 3. This is again 3. And for me, the team size is this person plus this person including him, that is 7. So if you observe that by doing this process, by walking down up from the leaf, By using only one iteration, we are finding out the each individual team size for everyone. मैं सबके नीचे कितने बंदे हैं वो गिन ले रहा हूं इंटर्न से शुरुआत करके. Okay, who are these interns? These interns are the leaf nodes. Okay, now we would do the same thing for this tree also. See, this all would return 1 because they are interns. For this person, the value from the interns plus himself, that is 1 plus 1 plus 1, that is 3. This person is an intern, would return 1. So for 0, the value from this side and this side plus 1, that is 3 plus 1, is equals to 5. This is how we would calculate the subtree size of each and every one. So now if you observe, yes, this person has 3 people, this person is a team of 3 people, this person is a team of 1 person, and this whole is a person of 5 people, and this person is a team of 1, 1, 1. So we can find the subtree size of each node by doing this process. Okay. Now, how we would find the cost? We can find the cost by using the same idea. Like we would say that from this node, the value is 0. So my child would have a distance of plus 1. This one would have a distance of plus 1. This one would have a distance of 2. This one would have a distance of 2. So for 5 only, as of now, for 5 only, we have found the value of 5. And these all are hidden values. That is 6, 5 we have. So, sorry, this value would be 6. We have found out 6 for the 0th value. So now what we have found out? We have found out the subtree size and the cost from one node. अभी तक मैंने सिर्फ एक नोड का बाकी सब के रिस्पेक्टिव में कॉस्ट निकाला है. फर्स्ट थिंग. दूसरा, सब नोड के अंदर कितने नोड्स है वो निकाला है. These are the two information I have found out. And what I aim to do, I aim to find out the cost of everyone. For 0 it is solved, but I want to find the cost of everyone. Do I make sense? अभी तक मैंने सिर्फ और सिर्फ इसका cost and this one's cost I have found out. Okay, so now we would be starting off. So now see, with the same mindset again. See, let's say we don't have the cost of anyone as of now. What we aim to do is we aim to find out the cost from just one node, and we want to find out the subtree size of all the nodes. Is everything good on my part? Yes. Okay. Now what I aim to do is the idea to find the, so first we would find the cost from one node only, and we want to find out the subtree size of everyone. How would we find the subtree size of everyone? Let's say I am at a company, and beneath me there are two members and beneath them there are two interns respectively for each of them. Now I want to know how many people are there inside everyone. Okay, किसके अंडर में कितने बंदे हैं मुझे ये पता करना है. How many people are beneath each person? So what I can do is to find out this. The interns gave a value of 1, and this person would just take the value from the interns and add and include them in the team size. So 1 plus 1 plus 1, that is 3. 1 plus 1 plus himself is 3. And this plus himself is 7. This is how you find out the subtree size of every node in just big O of n. Here, just replace these interns as the leaf node. So now we can use the same idea to have the subtree size of everyone. How? See, these all values would have 1 under it. This is 1 plus 1 plus himself, that is 3. So this would also have 1 beneath it. So 3 plus 1 plus himself is 5. So now we have the subtree size or the number of nodes beneath it for everyone. Like, yes, if you observe, this person has just himself. This person is composed of 3 nodes, that is why the value is 3. This person is just himself. Now, this person is these all people plus himself. That is how we would find out the subtree size for each of the node in just big O of n. So we now know that we can do this in big O of n time complexity. Do I make sense? Just give me a quick one. I won't be unsharing my screen or hiding my screen now. Just give me a quick one so that I can proceed. Chalo. So we found out the subtree size. No, we can do this from any, like we can consider anyone as a parent. Don't worry about that. You can consider anyone as a parent. Okay. Now I would arbitrarily select any node and find the cost for just him. Okay. So I would arbitrarily select any node and find the cost for him. How? I would inculcate here 0 and all its descendant would have a cost of plus 1, that is 0 plus 1. And all its descendant would have this as cost as 2, this cost as 2. And by adding up all this cost, for this node only, we get the cost as 6. And what is our aim? Our aim is to get these all values without calculating them. So again, we did find the cost for one node in big O of n. And we don't want to do this same computation for all the other nodes. We don't want to do that. We want to find it by using this idea. Okay, just select any node. I would select 0 because we have a habit or a standardized method is, and most of the time we consider 0 as the parent, kind of. So I would, in my mind, I have that mindset. That is why I would start the iteration from 0. You can start the iteration from anyone and that would give you the same result. So I found out 6 for this node. Still now I don't have this 5, this 8, this 8, this 9. I don't have this. I want to find out. And now we would see how we can find out. So the idea to finding out the idea is that let's say we want to find out the cost of this one to all other nodes. Like we want to find out 5 for this node. We don't have up till now 5. So the idea is that first we would find the total number of nodes. Total number of nodes. The formula to find out is total number of nodes minus total number of nodes minus the subtree size and add to it what? Total nodes, total nodes. This is the parent sum. This is parent cost. This is the size. And this is what? Total number of nodes. N, total number of nodes minus the subtree size it holds. Let's see if this is true or not. So let's say I want to calculate the value for this one. So the parent cost is how much? The parent cost is 6. The subtree size is 3 and n minus the subtree size is how much? We have 1, 2, 3, 4, 5. 5, 5 minus 3 is equals to 2. So if you observe, 6 minus 3 plus 2 is indeed 5. So now we have this hidden cost without the need to reiterate the whole tree. And we can use this same formula to calculate the cost for everyone. Let me show you one more and then I would explain how come this formula is, like I would tell you the intuition how come this formula is working. Now let us test this code, and yes, we are getting the correct answer. Let us test this code for this value. So parent cost is 6. The size of this subtree is how much? 1. And then total number of nodes is 5. And the size is again 1. So now 6 minus 1 is equals to 5. 5 plus 4 is equals to 9. And yes, by using this simple formula for everyone, we are getting the hidden value. We don't really need to reiterate that. So for all the members of 6, we can find out. And for all the members of them, we can again find out. And this is how we would find out the hidden cost for everyone. Now let us iterate and first find the hidden cost for, cost for everyone. And then I would explain how this is working and how this formula is working. Okay. So as of now, we have found out 5 and 9 for these nodes. Now let us find more of it. So now we would use the parent as 5 and we would find the cost of these two. So parent's cost is how much? 5 and the size of this is how much? 1 plus total number of nodes is 5 and the size that is same 5 minus 1. So now 5 minus 1 is equals to 4. 4 plus 4 is equals to 8. And see, we have found out this hidden cost 8. This is correct. Again, for the below one, the parent's cost is 5. Like we have found out for this, only this one is left. Again, we would say 5 plus 1, that is the subtree size. And again, 5 minus 1 is equals to 4 plus 4 is equals to 8. So again, we have found out this. So we only need to find out the cost for one and the subtree size for everyone else. And by using up this formula, we can find out in constant time the values for all the other nodes. So if you observe, what is, so to find out the subtree size, we are doing big of n operation. To find out the cost for just one node, we are again doing big of n operation. And that by using that cost, we are calculating the cost for everyone else in constant time. So this is again big O of n. So 3 big O of n. So cumulatively in big O of n, we can find the cost for everyone. And here we don't really need to reiterate for everyone. Now let me show you how this formula is working here. So now let me again remove all the details and let me just show you how this formula is working for this. How this formula is working. This is basically a formula and you need to remember it. But still I believe that how this is working is required to understand. So parent cost is 6. So parent cost is what? Parent cost is nothing but the cost to all of them. And when we are subtracting the size, so if we remove this, that is 6 minus 3. If we remove this is what? This part is nothing but some distance if we remove. If you observe the sum distance, if we remove one, like if we remove this part, if we remove this node, the sum distance is 6 minus 3, that is 3. Okay, this one is this. So this is this. So this is the formula, and this is, and then we add that what is. So it's just like we shift the root. We shift the root by one node and we find out. Then we again we use the found out value and we shift the node. This is just like the idea of rerouting and finding out the centroid. Okay, let me show you the solution. Yes, we need to find out the first parent using brute force. Rerouting concept. Okay, we can consider anyone as parent, but we need to find out the first parent using brute force. See, if we want to calculate for one node only, if we want to calculate the distance, it is big of n, I understand. But by using that big of n, we can calculate the values for all the other nodes. Let me just show you. See, first what we do is we just find out the answer for just one node. This answer we are keeping here, the answer for just one node, and we are finding out the subtree size of everyone. First we are doing the DFS, and then we are adding the subtree size, and then we are adding the cost also. And by using that cost, we are finding out the number of nodes is count of 1, left node is n minus 1, and answer to the current node is this, and then we are just calling for recursively for the below nodes also. First you are using that as a base node and calculating the values for its descendant, and then using them as the base node and then calculating them for the base nodes. This is what we are doing. So first we are making out the adjacency list because we don't want adjacency matrix, and then we call the both DFS, and after we have found out the answer, we found out the minimum cost and the minimum value, and this is how we return the answer. This is just like the rerouting concept. Not just like, this is the rerouting concept where we just shift it and find out. Understood? Anyone who has not understood, give me a 0 in the chat, else I would move forward. The last question is comparatively towards the easier side, I would say. Do I make sense to you? Give me a quick 1 in the chat. Others, please give me a 1 so that I can move forward. Today, this question had a lot of sharing issues. No? Everyone understood? See, basically, if you would have solved up this problem, if you if you want, I can give you some problems which kind of revolves around this idea. Let me give you some problems which revolves around this idea. So this is the problem which revolves around this idea. If you want to know right centroid, calculation of centroid, and then solve up this problem also, if you want to know more, and this is a very generic way to do it, the rerouting concept. Okay, let's move forward and see the last problem. Okay, geek and geekina. The cost of the array is teacher assigned them. Number of operation to convert x to 0 or 1. In each operation, what you can do, you can take any prime factor of the remaining values and subtract it from x. Any prime factor of the remaining value and subtract it from x. Done. Chalo. Let's take up the second example. Mhm. So what this question basically wants, like the question is kind of exaggerated. Damn, sorry, I just clicked it by mistake. The kind of this question is exaggerated a bit, but the problem statement should be simple enough. But this is meant to confuse you. So see, what they want is they have given you two arrays and they want you to find the number of operation required. Let's say this array requires 100 operation, this array requires 90 operations. And this number of operation is calculated by adding up the number of operation of each value. So whichever has less value, that person would win. So if cost of the first array, if the cost of the first array, if A1 cost is less than equal to A2's cost, then we need to return 1. Damn. If A1's cost is less than A2's cost, if A1's cost is less than E2's cost, we would return 1 to it. Fair enough? So the whole point is finding out the values for each. So for 10, the number of operations required to convert it to 0 is this. For 10, what we can do is we can subtract from 10, we can subtract 5 from it. Then again we can subtract 5 from it. That is, we can subtract the prime factors and make it 0 or 1. So these are two operations. So for 10, the number of operation required is how much? 2. So for 9, the prime factors are 3 only. So we would subtract 3 and we would get 6. Then for 6, we have the prime factors and 2 and 3. So we would subtract the greater one. So again, we have 3. And then again, 3 is a prime in itself. So again, it would become 0. That is why the number of operations are 1, 2, and 3. Okay. So for 9, we need 3 operations. So same goes for 6. We need 2 operations. So when we draw the number of operations for 9 and 6, you can see a small hint here. The hint is that if you observe here also, after 6, here also we are calculating this value. Here also we are calculating the same value. Okay. And see, here also we would calculate the value for 9. Here also we would calculate the value for 9. Okay. So if we calculate the value for a very large number, let's say for a value, big value like 24. So what are the prime factors of 24? We have 2, we have 3, we don't have 5, we don't have 7, we don't have 8, we don't have 9, we don't have 11. So let's say that the value, let's take a small value, finding out the greatest prime factor. So for the value 10, here you are converting to 5, then you are converting to 0. So by finding out the value for 10, you found out that 10 requires 2 operation, 5 requires 1 operation. If you find out the value for 9, 9630. So you found out that 9 requires 3 operation, 6 requires 2 operation, 3 requires 1 operation. So this gives me a hint that this is a overlapping sub problem. Here, by writing out the values only, we can see that this is overlapping sub problem. For 6 also, we are doing 6, 3, and 0. So this is pre-processing. So we can use pre-processing to save the results. The first point of concern is what do we all want? What are the requirements here? Very simple requirement is find the prime factors. Find the prime factors of everyone. So finding out the prime factors for everyone, let's say we want to do it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say we want to find out the prime factors for everyone. So you can use sieve to find out the prime factors for everyone by using the concept of smallest prime factor. So we can store the smallest prime factors and we can find out the prime numbers. So we would use sieve here. So initially everyone is a number, everyone is a prime in itself. So we would everyone is prime. Okay. So let's draw a big value. Okay. So, mhm. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So initially everyone is a prime number in itself. So initially everyone is a prime. Just like we do it in sieve. Now we would start with the value as 2 and all the numbers as 2 is a prime up till now. So we would take out all the numbers multiples of 2 as composite number. Is everything correct? Yep. So we would take out all the values. But instead of just taking out, we would store, which is the first number, which is saying that this number is a prime. So here we would just say, this is just like this concept. Like let's say we say na, first love can never be forgotten. So every composite number would store its first love or the number which is hurting it. So to hurt the very first number which gets hurt from 2 is 4. So we would say 2 gave you a hit, 2 gave you a hit, 2 gave you a hit, 2 gave you a hit. Then we go to 3 and we say 6 is already hurt. 6 is already hurt. 9 is not hurt. So I would say 3 hurt. So we go to 4. 4 is not saved as composite. So we can't really hash out the multiples. 5, 10 is already done, and then we don't need to do anything. But by doing this, you should observe that we found out the smallest prime factor for 4, smallest prime factor for 6, smallest prime factor for 8, smallest prime factor for 10, and smallest prime factor for 9. Now, if we want to find out the prime factors, what we can do is, if we want to find out the prime factors of 10, we would go and ask, who is your smallest prime factor? I would say 2. I would add it and then divide it by 2. I would get 5. 5. Who is your smallest prime factor? 5 would say no one. I am a prime in myself. So the prime factors of 10 is 2 and 5. Let's do the same thing for 6. If we go to 6, 6 is divided by 2. So we would divide 6 by 2 and add 2 as prime number. Then we go to 3 and we ask, who is your prime factor? 3 would say, no, I am a prime factor in myself. So the prime factors of 6 is 2 and 3. Let's do it for 8 also. So 8, we would go to 8, he would say 2. So I would go and write 2. Then I would go to 4. 4 would say me, yes, 2 only. So I would add 2 again. Then I would go to 2 again. Now 2 would say I don't have any prime factors. I am a factor in myself. So we found out all that. This is how we would use the sieve method to find out smallest prime factor. And by finding out smallest prime factor, we can find out the prime factors for each of the number in the most efficient manner. Do I make sense? How to find out the prime factors for many numbers using the sieve method. Do I make sense? Just give me a quick one. Like for a range of numbers, if you want to find out the prime factors of it, you should use sieve to calculate SPF, and by using SPF, you should be able to calculate the prime factors of it. Give me a quick one in the chat. Can you use this? So by using up this array, I would find out the prime factors for everyone. So by using up, I found out that the prime factors for 2 is 2 only, 3 is 3 only, 4 is 2, 5 is 5 only. This is what? This is smallest prime factor, and these are the prime factors. And for 6, the prime factors are 2 and 3. For 7, the prime factor is 7. For 8, the prime factor For 8, the prime factor is 2. For 9, the prime factor is 3. For 10, the prime factor is 5 and 2. So we would only keep the largest value. That would work. Don't worry. Keeping the largest value would solve the purpose. Now, we want to calculate how much operations would be required for each numbers. Let us do it. So we would start with the very lowest value, 2. So we would say the number of operations required. So this is what? Number of operation required. So for 2, the number of operation, like if we subtract 2 from 2, the number of operation required is just 1. If we go for 3, 3 minus 3 is equals to 0. The number of operation required is just 1. If we go to 4 and we subtract the smallest prime factor, that would be 1. And then after subtracting it is 2. Then we would go to 2 and ask, what was your cost? Can you tell me again? He would say 1 only. So I found out that for the value 4, the number of operation required is 2. Now for 5, if we subtract 5, the number of operation required is 1 only. Now for 6, first we would subtract 3 from it. And then we would go and ask 3. 3, what was your result? We are using the same result for 3 because we have already calculated for the lower values. 3 would say 1 only. I would say okay. And I would say 2. So see how we are using the lower values which are already found out. So 7 minus 7, 0. So 1 cost only. 8 minus 2 is equals to 6. So 1 plus the cost of 6. 6 tells me that the cost is 2. So the 8 would require how much operation? 3. 9. I subtract 3 from 9. And what is stored in 6? 2. So 3 again. Then I subtract from 10, I subtract 5. And 5 cost is 1. So I would say cost is 2 only. So see how after finding out the prime factors, we are able to find out the number of operation for all the numbers, and this is how we would find out the number of operations for all the numbers, and then we would compute this sum for each of the array. Whatever is the lower cost, we would use that. Make sense? Now let us see the code for it. Mhm. Let me just copy the code and make it more wide. Okay, see bacha. First, we are using the sieve method to find the SPF. So if it is a prime, then all the numbers it is striking it, we would save that number who is striking. We are saving the first love. Then for finding out the factors, what we are doing is we keep dividing it and we keep adding the prime factors in an unordered set. Unordered set, why? Because 8 would be getting divided by 2, 2, 2, again 3 times 2. And we don't want 3, 2. We want only one occurrence of it. That is why we just save it in a set to get all the unique factors. And then we would just return that as a vector. Now for pre-computation, what we do is we first find out the maximum range till where we need to calculate the prime factors. Instead of that, what you can really do is, instead of that, you can do something like this also. You know that the maximum value of a of I is 10 to the power 5. So you can directly use something like 10 to the power 5. 10 to the power 5 plus 1. That is also same. You don't need to find out the max range. But if you find out the max range, that would be more beneficial. Then you find out the prime factors of it. Okay, initially you mark everyone as a prime of itself, and then you find out the SPF. And now what you do is you use the previous computed value and you add 1 to it. And then you find out the answer for everyone using dynamic programming approach. And then you use the pre-computed result to find out answer 1 and answer 2, which if answer 1 is less than answer 1, we return 1, else we return 0. This is the solution. That is why I thought that this is comparatively on the easier side, because when you start learning about the different algorithms, the very first or fifth algorithm you learn is sieve method. So I think that, so anyone who is not able to understand this, please give me a 1 or 0 in the chat. So this is why the rerouting deep is the rerouting technique. We learned it towards the intermediate, but even if you're a beginner, you learn sieve method. That is why I think so that the last problem should be ranked as third and third should be ranked as fourth. Okay. Can someone please tell me why my code for the last, even though it's within the term limits, I pasted the code on the contest discussion page. Okay. If no one is helping you, consider asking me on LinkedIn. My LinkedIn URL is this. And if I get time, I would definitely help you debug your code. So anyone who has not understood, there is absolutely very less number of people present here. So I don't think there is a point in waiting. So that was it from my side. I tried my level best to explain each of the question. Now I am also thinking of giving you the solution in Java as well as C++, because Java has comparatively a different way of implementation. So let me know how many of you need this. So I tried this in the best of my knowledge, and like I tried my level best so that you don't get affected. Like I kept the explanation for the first two problem on the concise part. The first problem was the most concise, then the second problem was a little less concise, and I tried to explain with a dry run. This time what I did was, instead of like for the past many contests, what I did was I tried to explain you the solution in terms of concepts. But this time I found out that many people gave a feedback to me on LinkedIn that said that instead of explaining the concept, you should do a dry run how this is working. This is the first time I inculcated, like, to be honest, like if you see my copy, I kept a sample tree where I could do the dry run, and I kept this. So this was the first time where I kept a test case for each of the question towards the last part. So let me know how many of you think that I should continue this. So let me know your views on this. That's it for today. I think so. Goodbye, everyone. All the best for your future endeavors. Thank you, everyone. So, if you are a person who is watching this stream in the recorded version, consider commenting a 1 in the chat so the reach of this video could be increased and this hard work on a Sunday late night could be justified. Thank you, everyone.